like this frame. Can you see here this frame? So if there is a pin, then first you have to find out two reactions at this point. How you can do that? You can divide into two parts. The first part, another part, show the reactions here, and then find out the reactions. It is the same example which you have done in chapter 2. It is very similar, and I think you have this type of question in your exam as well.
Yes.
Same.
Yeah,
So once you have these reactions, then you can draw the bending moment diagram. Like for this frame, for this, let me go down. Yeah, this is the, this example we did in our last class. This example is also similar. There is no difference. Only you have to make this load perpendicular to this member by taking cos of this angle. So if you take the cos of this angle, you will get two loads. One horizontal load like this, another vertical load. That is the only difference, nothing else.
How we draw it?
Which one?
This with slope. Same, draw it horizontal and vertical.
For example, if you have a load, suppose if you make this load like this, so there will be two components. One component of the load is horizontal. This horizontal will not make any effect. It will not create any bending moment and shear force. But this component, you will be having reactions here. So like other members, you can draw the bending moment and shear force diagram. This component, it will not create any bending moment or shear force. It is like axial force. This component will be like axial force and it will be balanced by these reactions.
So the drawing will be like this?
No, it will be like this. Yeah. Just like beam. Now your beam is at an angle.
We'll begin with the reaction.
Yes, whatever. I don't know the values. Yeah, like this. And then the bending moment will be something maybe like this. It depends upon what type of support is here.
So because any slope, we will make the drawing as a slope.
Yes, you will draw. If you go to the example, the previous year, this one, see something like this. This shape depends upon the values. If the value is very high, it will not go down. It will be finished here. Okay? But it is the same way. So there is no complication even if the load is at an angle like this. It seems very difficult. For example, what is the idea? The idea is to make the load perpendicular to the member. If you have this load is not perpendicular to the member. You understand?
Yes. Make it as slope.
So how you can make it? You
We'll
can
divide with 4/5.
You can find this angle. You can also find this angle. And then you can make it vertical like this. Okay? And then the same way you can draw the shear force and the bending moment diagram.
So how this load is occurred? There is no any member in the air.
It is actually the load on this member. This is the load actually on this member. You think that the load is stopped here. Load has a line of action. This load is moving, this load is in this way. If there is no member, I understand that. If there is no member, so this load is on nowhere. This is, I think, your question. But this is not right, because if you have a load passing through a line, so this load will remain same along all this line. Do you understand or not? This is, I think, the first chapter, maybe in your statics or something. That the load on line of action, it remains same. So the same thing, you can consider this load something like this.
How we convert it? By cos.
Yeah, you should know this angle,
Then
and
cosine.
from this angle you can
Cosine.
take it, convert it.
It will be same 40. Is that?
No, it will be different depending upon this angle. How much
Be
is
less.
this angle?
Because of unit length. How we convert to unit length?
40 kilonewton
Cosine.
into 3
Okay.
over 5 kilonewton per meter.
First, you should convert this load. There are two ways. The one thing, you can convert this load into a point load, like this.
Yeah. Okay.
If you are getting angry with this, convert it into this load and now make it into two components. One component and this will be the other component. Okay? So now again, you want to convert this load into a UDL. How you can do that?
Divided by meter.
Divided by the length.
The length.
Divided by this length.
Yeah.
Which will be 4 plus
Square.
And
Square.
3 over 5. Yeah.
So just divide this load by 5. You will get UDL per unit length. Okay? I think it is easier way. How many of you do not understand me, what I am doing here? How many of you? Raise your hand.
Teacher, like directly divide by 5 or the cosine theta, which would be 3 over 5.
You know, you have this load.
Yes.
So you already converted this load based upon this angle into two components.
Yes.
So now again there is no need to take any cosine or something. Do you understand?
Yes.
Because you have already converted this component, how you will get this load? By this angle.
Yes. Sine.
So there is no need again to apply cosine or sine. Okay? What I'm saying, okay, let's see here. I think he has done the same, exactly the same way. If you see here, this load is divided into two parts. Okay? 72 and this one based upon this angle, and then yes, 72 divided. This is same example or different example? Same example. I don't know. If it is the same,
Different.
okay. If it is the same, then 72 divided by 5. How much is that? 14.4 it should be. 72 divided by 5.
14.4.
So this is, see how you get that UDL, 14.4. This load 72 divided by this length,
Yeah.
5, you get this load. And now you have these reactions, so you can draw the bending moment and shear force diagram for this beam, whatever. Any question? No?
How we convert this 40 to 14.4?
How we converted 40 kilonewton per meter to? Okay. I'm a little bit fast because I want to start the new topic. Okay. You had 40 kilonewton per meter. For example, it is the original load. So how much is the total load? 40 multiplied by this height.
3.
120. So it means the load here is 120. The load here is 120. Okay? Loading time. Now we want to, because I told you the load should be perpendicular to the member. So we need now two components. We can find out this vertical component and this horizontal component. Now for that we need this angle. And this angle will be equal to this angle. Okay?
So theta
What is that? How much is that? Can you calculate?
36.
36.8. So 36, this component will be 120 cos of 36.8. How much is that?
Sine.
This component will be cos, I think.
No.
Yeah. The horizontal is
I
cosine.
mean vertical.
Cosine.
So this component will be 120 cosine 36.8.
Minus 6.08.
96 point.
Point one.
And what about this component?
Sine.
120 sine 36.8.
71.9.
You can say 72. Now you can divide this load 72 divided by this total length.
Yes, look at your rate.
Divided by 5.
14 kilonewton per meter. How you get it?
Over 5. 32 over 5.
The same way, if you want to convert this load into UDL as well, you can also do that. Divide 96 by 5. You will get a UDL something like this. And this UDL will be 96 over 5. If you wanted to do that. Now you have two reactions. One is here. Another is here, like this. It's a pin. And it's a roller. I can see it's a roller. There is. Okay? So now you can, you know this reaction, you know this value, you know this value. Okay? Now you can first bring this member into equilibrium. Or you can draw the shear force and the bending moment diagram this way. Okay? So, this
96
is
is how we draw it.
how we draw it.
96.
96, this load will not produce any shear force and bending moment. If this is your beam and the load is like this,
It's compression.
it's either compression or tension. This load will produce bending moment, which is perpendicular, and this vertical load will try to shear the beam. The horizontal load produce normal forces. Maybe this horizontal member, this horizontal load, for example, this horizontal load, maybe this way or other way, it will have two components. One component horizontal and one is the vertical. And this component will produce a shear force and bending moment on this member. Okay? Which we have solved in our previous class, in my previous lecture. You can go and you can see that how the axial force in one member is the shear force in the other member. I think we solved this example in our last class. Okay? This is the same thing, the same story. These are the reactions. You can find out the reactions very easily, no problem at all. Once you have these two reactions, you can also convert these two reactions into this reaction and this reaction. You have this angle. Okay? Well, it's all statics. I'm not going to tell you in detail how to calculate the components and convert along the different axes. It's all statics, and I expect from you that you have a good knowledge of statics. This is my expectation, my assumption. Because you always move by some assumptions. So when I am teaching you this course, my assumption is that you have a good knowledge of statics and strength of material. Okay, this is my assumption.
Mathematics, yes, but
So as we do the same thing, for example, when we design any structure, in the beginning we take some assumption. So when I started this course, and that is not only the assumption, that is, I think you have already studied, you have passed this course, these two courses. You have passed strength of material and statics. That's why you are sitting in this class. Am I right?
Yes.
Good. Okay. The main task was this frame, which was a kind of disturbing for you. It may disturb you, but for me it seems very simple. I can see that this support is a hinge.
Yes.
That A is fixed.
And this support is a
Fixed.
fixed.
B and C are.
I'm not sure, I should read the question. If you have in your book, you should read it. Because
لا problem.
it is 449.
41.
Assume the frame is pin connected at B, C and D and A is fixed.
Draw the sheet one diagram and A is fixed.
Assume the frame is pin connected at B, C and D and A is fixed. Great. You know pin. So pin at pin we have two reactions. Now first step we have to find out the reactions.
Yes.
We have to find out the reactions. There will be two reactions here. Three reactions here. Okay. So what we can do, and two reactions here, two reactions here. For example, let's start from here. Member DC. There will be two reactions. You can assume this one is VD and left to right
Left.
HD. And this is a pin. So you will be having two reactions here as well.
B, C.
H, C and B, C. Okay, so from here you can get two informations. The first information, BC is equal to
PD.
and HC is equal to
HD.
HD. Now go to the other member. This will be V,
D. Oh, no. DC.
C and C. Now when you come to this member, you should show the opposite way.
Yes.
Okay, and here you will be having again two reactions. The one reaction
HC equal HB.
Yeah, equal distance, equal loads,
VB
and HB.
Now you have three loads and these loads are known to you. This distance is known to you, 24. I will call meter. All these I will call meter because I am teaching you in kilonewton. 6 kilonewton, 3 kilonewton. Now you can find out VC and VB.
It's 9 each.
Just take sigma. Just take a moment at this point. The moment at this point is 0.
Who will give you this?
You will get VC.
If we have 4 nodes, why you can say? It's just
Okay, sorry. I forgot.
And the 3 Newton and the HC.
You find VC. Okay? You find VC.
D9.
See, such a beauty. And once you have VC, you have VB.
And you have
You also have VB.
yes.
You also have VB. Sigma Fy, you will get VB. Take moment at this point, you will get VC. Sigma Fy, you will get VB. And once you have VB, now come to this member. Now, if you have for these two members, like this member and this member, you can draw the shear force and bending moment diagram. If you apply sigma Fx,
HB will equal HC.
HB will equal to,
C, which also equal HD.
is also equal to
HD.
HD. Okay. So it is known to you Okay, what I do now, it is VB.
VA.
Let me tell you one thing. You know what? You can also have the moment at this point. You can start from here. You can draw. Once you have BC, you can find out that on this member there will be. On this member, you can draw the shear force and bending moment diagram. Once you have BC, HC and HB, they are not producing any shear force and bending moment. Okay? What is the question exactly? Can I read the question? Pin at B, C, D and A. A is fixed. You know what? If you apply sigma Fy, you will get VA. You will also get VA.
Just 9 as well.
Okay? And now the moment. But before that, what I was telling you that with VC and BB, you can draw the bending moment diagram for shear force and bending moment diagram for this beam. How many of you do not understand till now? Do not understand? Okay, so do one thing. I give you one exercise. Just try to solve this question at your place and then come to me. Okay, I give you this as homework. For all? For all of you. Homework. You have to submit this question.
Okay.
This one?
Which question?
Or this question. Okay?
Okay.
So it is a homework that you have to submit me by next week. Solve this question, and if you do not understand, come to me. Because this is the only way by which I can force you to think. Okay? Do you understand or not?
Doctor, make the homework 5%.
This is, I will decide at the end. But, I mean, don't jump to solution manual. Else you will destroy the whole idea.
The principle of.
So, okay, don't look on the solution manual. I know you can find it online or you have it.
We already have.
I know. So, my question is that don't destroy my idea of forcing you to solve this question by looking on the manual.
Just to check.
You can come to me. This is what I'm saying. I want you to see you. I want you to meet in my office. You understand? So if you do not understand, then come to me. Then I will teach you in person. I mean, without any charge, extra charge. Okay, so I think if we have started by this, it's much easier than that one, this one. But before going to this one, you jump to that one. So anyhow, it's not a big deal. Okay. So the same way, if you have a hinge like this, if you have a hinge, you have to find the reaction at this point and at this point. This is the same problem, B, C and D. You know, if you calculate, now if you have reaction here, I'm back, welcome back. If you have reaction here, okay, you have reaction here. And at this point, fixed. If it is a fix, you take a moment at this point, M. Okay? Please try to understand. This is what I'm now. It is a last concluding point. If you understand this point, then you have no need to see the manual. You will be having two equations. The equation 1 from the overall equilibrium. In the overall equilibrium, you have two reactions here and two reactions here. In fact, three reactions. One is a moment. And then you have this member. In this member, when you take it in the isolation, you have one M and you have one. Just try to understand. You will get two equations. One equation, just consider this overall structure. When you consider this overall structure, and you can take moment at this point, this force will be gone, this force will be gone.
Two and one.
Moment and
BG.
This you know.
Oh.
Already you know.
yeah.
This,
From the separation of.
for example, you have one reaction here.
Yeah.
Oh.
From separation of.
Separation.
You already know this reaction.
Yeah.
So this reaction is equal to this reaction.
Yes.
You understand or not? This reaction is known to you. So if you take moment at this point, you will get this moment. Do you understand or not? Well, I'm going to delete the whole idea of starting the new topic and I'm going to solve it if you do not understand.
Yes.
See, you have this reaction. This reaction is equal to this reaction.
Yeah.
We made a beam, this beam. And we found that this reaction is equal to BD, VC, they are equal. And this is VC. VC you get it from here and this is VB. So VC is equal to VD and you know how much is VD. Any value like maybe 5 or 15, whatever. So if you take moment at this point, what you will get? You will get moment.
Yeah.
Okay, let's suppose VD, it is 515 kip. Yes, let's suppose it's 15 kip. Let's suppose.
Moment that day.
So then take moment at point A, you don't know what is that.
Yeah.
It is not 0. This is what?
0.8.
0.8.
So
Take 12.
you can assume that the moment at this point is, let's suppose, counterclockwise. You can assume. So you can take it positive.
Yeah.
And it is clockwise
Yes, clockwise minus.
plus 0.8.